So today we're going to divide polynomials, and we're going to do two methods. We're going to use long division and synthetic division. So if you look at the very top, let me grab my ink pen. Kind of look right here. When you remember dividing from whatever day in middle school you did that, and just kind of review the operations that we said. We said 6 would go into 145. And in order to do that, you kind of say, hey, 6 doesn't go into 1, but 6 goes into 14. How many times does 6 go into 14? Well, 6 times 2 would give me 12. So I did this number times this number to get this number. Then I drew a line and I subtracted, right? Whatever was underneath, I subtracted. So 14 minus 12 was 2. Then I brought down the next term and I started over again. How many times does 6 go into 25? Well, 6 times what number is going to give me 25? Well, 6 times 4 is 24. And I don't have anything left, so my remainder will be 1. We're going to use the similar concepts to that. Like we're going to apply those same rules, but obviously it's going to be much more difficult when we do polynomials. So take a look at part A. We're going to solve by using long division. We have x plus 2, and we're dividing it by x squared plus 5x plus 6. The way you start long division is you say, how does x going to become x squared? Okay, just worry about the first term. So how can x become x squared? What do I need to multiply by? Well, if I multiply it by x, let me take x times x, that gives me x squared. But I also have this plus 2, so make sure you multiply that by the x, so plus 2x. Now, once you multiplied x plus 2 times what you decided to put up top, when I draw my line, what I need to do before I subtracted, right, I need to subtract again, but you got to be careful. There's multiple things here. So I say, as you draw your line, you're going to change the signs of the terms that you've written. So like when I have draw my line, I'm going to change this to a minus, and this plus I'm going to change to a minus. I have to change my signs because essentially what I'm doing is subtracting. Okay, when I do that, I'm just going to do a different color. The x minus x squared will go away. I have 5x minus 2x. That leaves me with 3x. And just like in my other long division, I bring down the next term. Okay. Now I'm going to start over in the sense where I'm going to say, okay, I have to match up x plus 2. How does this become 3x plus 6? Well, just worry about the x term. How does x become 3x? What do I need to multiply by? If I multiply by a positive 3, 3 times x would be 3x. But I also need to multiply by the 2, so 3 times 2 is plus 6. Now, if I go to draw my line and change my signs, I'm going to draw my line, change this to minus, and change the plus to a minus. These cancel, and I don't have any remainder. So my answer would be x plus 3, right? That's the expression and the polynomial that stands for if I divide x squared plus 5x plus 6 divided by x plus 2, this would be my solution. And because it divides in evenly, this x plus 2 would be a factor of my divisor. All right. Now, number 2, I'm doing the same thing. They just wrote it, okay, where I'm going to have a trinomial and divided by a binomial. So what I'm going to do, you come back. It's for Pat. Sorry, I'm recording a lesson. You're fine. Coach Green's here. He's bothering you guys. So no.
I was going to tell you that is not an invoice. That's a statement. I'll get the invoice later.
Okay, good. Okay, cool. Thanks.
Hey guys, listen to this lady. She's smart.
She draws well too.
So problem 2, we're going to take x minus 8 and we're going to divide it into 2x squared minus 19x plus 24. All right, so we're just going to write the division ourselves. We're going to start it out. I'm just going to change pen so you can see it better. How does x become 2x squared? What do I need to multiply x by to get 2x squared? Well, if I multiply it by 2x, that would get me 2x squared. And I want these first terms to match up so I can subtract them out. But you have x minus 8 here, so I can't just multiply the x by 2x. I have to multiply the negative 8 as well. So x times 2x was 2x squared. Negative 8 times 2x is negative 16x. Okay. When I draw my line, I'm going to have to change my sign. So I'm going to go back to the red. I'm going to change this sign, and I'm going to change the negative to a positive. And then I'm going to combine my terms. So these cancel. Negative 19x plus 16x is negative 3x, and then I bring down plus 24. All right. Now I'm going to say, how does x become negative 3x? How can I make x become negative 3x? Well, if I multiply by a negative 3, multiply both terms out front by that negative 3, I get negative 3x, and then I would get plus 24. All right. If I draw my line and change my sign, so there's my line, I'm going to change this to a plus, and I'm going to change this to a minus. All of that goes away, and this is another problem that works out nicely where I don't have a remainder. Okay, let's look at number 3. We're going to start out by saying, how does x become x squared? So x times x would give me x squared. So that would give me x squared, but then multiply it by the negative 2, so minus 2x. All right, so I have x squared minus 2x. I'm going to change my pen color so you can see. I'm going to draw my line and then change that sign and change that sign. Make sure when you draw your line you change your sign, or else the rest of your entire problem is going to be wrong. Those cancel out. 3x plus 2x is 5x, and then I bring down the next term. Here I go again to start over, where I'm saying, okay, how does x become 5x? What do I need to multiply by? If I put a plus 5 in there, 5 times x would be 5x. 5 times negative 2 is negative 10. I'm going to draw my line and change my sign. So draw my line, change that to a minus, change that guy to a plus. These go away, and I actually have a remainder of negative 2. Now, kind of the grown-up way of writing remainders is to take my answer is x plus 5, and I'm going to add to it whatever the remainder is over the divisor. So when you want to write your answer, that's what it's going to look like. We're not going to put r of negative 2 anymore. Okay, you're going to say whatever you get, kind of what your dividend is, plus the remainder over your divisor. All right. Now, number 4, they can write it like number 2, they use a division symbol. Number 4, we just put something over something. All of these mean the same exact thing. We're just doing division. All right. The problem with number 4 is that you have to be careful, because when I go to divide, all right, if you look carefully in the numerator, I'm missing an x squared term. And that's a big deal, meaning if I'm missing any term when you do division, you need to fill in that term with a 0. Okay, so what I mean by that is I'm going to write x cubed, but because I don't have an x squared here, I'm going to put plus 0x squared. I need to kind of have a placeholder for that. I'm going to leave the minus 3x and leave the 8. And then we're going to go ahead through and just do long division like we did before. So how does x become x cubed? Well, I would need to multiply by x squared. Multiply that x squared by both terms out front, so x cubed plus 2x squared. And you'll see right away I needed that 0, so I would line up the x squared with the x squared and not make a mistake and line it up with a different term. Okay. After you multiply, we're going to draw our line and change our sign. So draw the line. This changes to minus. This changes to minus. Those cancel. 0 minus 2x squared is minus 2x squared. And then you bring down your next term. We're going to start over again and say, okay, how does x become negative 2x squared? How does x become negative 2x squared? I need to multiply by what? Well, negative 2x, right? So take the negative 2x, multiply it by both terms out front. So negative 2x squared minus 4x. Now I have to draw my line and change my sign. So if I draw my line, change the negative that was there to a plus, so that way these will cancel. This negative changes to a plus. Negative 3x plus 4x is x. And then I have to bring down the 8. Okay. The last step, I have to say, how does x become x? Well, x multiplied by just a positive 1. That's okay to just put a 1. X times 1 is x. Positive 2 times 1 is positive 2. If I draw my line and change my sign, my remainder is going to be 6. Okay, so what I need to do is write my final answer as x squared minus 2x plus 1, and then my remainder is 6. I'm going to put that over what my divisor is.
My life is frustrating right now.
All right, so that's answer number 4. Go ahead and try number 5. It's a little bit tricky because we are missing an x term, but go ahead and try that. Press pause in the video, and then come back and check your answer. Okay, so on number 5, if you started it out, x squared becomes 3x cubed. I need a 3 and an x. So if I multiply through, I get 3x cubed, but then I get minus 27x. Now you got to be careful. If I have minus 27x, that needs to go in the column with the x's. Do not put it with the x squareds. All right? It's okay to line it up. Just make sure you're lining up like terms. If I go ahead and draw my line, and change my signs. So change my sign. This 27 is going to become positive. Now, don't freak out. This is just going to drop down because I'm really adding 0 to it. So I have negative 2x squared. I'm going to add 4x and 27x. I'm going to get 31x. And then I'm going to bring down the plus 1 that was up here. I'm going to start over again and see what I can match up. So I'm going to say, how does x squared become negative 2x squared? Well, I'd have to multiply it by negative 2. So x squared times negative 2 is negative 2x squared. Negative 9 times negative 2 is positive 18. But I don't want to put it with the x's. I want to put it over here. So I'm going to draw my line, change my sign. When I change my sign, I would usually like either circle them, actually change my sign. This is going to be changed. Just drop down the 31x. 1 minus 18 is negative 17. Now that's my remainder. Here's the reason why it's my remainder. I can't put x squared into an x. Okay, I can't do any more division. So once you can't do any more division, this is going to be my remainder. So again, I'm going to take my answer, okay, to write it kind of like a grown-up. I'm going to say 3x minus 2. Yes, that sound is Patrick going to the bathroom. Okay, 3x minus 2 plus 31x minus 17 all over x squared minus 9. So that's how we kind of want to write our big boy answer. All right, so that's long division. What's nice about long division is you can do any polynomial division with long division. All right, now there is a shortcut we're going to do next, but there are limitations to that shortcut. So long division is the best thing to divide polynomials because it will work for anything you do. Okay, now we're going to do similar problems. Okay, some of the same exact ones, but we're going to use something called synthetic division. Now, it's going to seem confusing at first, but once you get the hang of it, it's going to be much easier, and you're going to like synthetic division better. All right, what you're going to do is, let's look at our original problem. The first thing you do is I'm going to make this little box here, okay? And within this little kind of half a square, I'm going to put the 0. So I'm going to kind of put this up here. I'm going to put the 0 of the function. And what I mean by the 0 of the function is if it's x plus 2, the 0 of that would really be negative 2. It's really the opposite because I'm thinking about what the x-intercept would be. So if I have x plus 2 here, in my little box, I'm going to put negative 2. All right. The second thing you do is I'm going to line up, I'm going to line up all my coefficients. So I'm going to write down, this is kind of what you do in general, and then I'll do it for the problem. I'm going to put all my coefficients in order, and you have to make sure you hold places if there isn't an x squared or an x. So what I mean by that is my coefficient of x squared is 1, my coefficient on the x is 5, my coefficient on the x is 6. Or excuse me, the constant term is just 6. So once I put in my 0, my coefficients, I'm going to draw a line here, okay? You're going to bring down your first term. So for this problem, I would bring down my first term, which is 1. And then the process to figure out how I fill in synthetic division is I'm going to multiply going diagonally, and then I'm going to add going vertically. So let me show you. I'm just going to say, what is 1 times negative 2? Multiply those two numbers. I get negative 2, so put it here. After I multiply, then add going vertically. 5 minus 2 is 3. I'm going to do the same thing again. I'm going to multiply diagonally, so 3 times negative 2 is negative 6, and then I'm going to add vertically. Negative 6 plus 6 would be 0. Go ahead and box off this last number. This last number is always going to be your remainder. All right? This is your remainder, and then we work backwards. This is going to be our constant term, and this is going to be our x term. So what I mean by that is my answer is 1x plus 3, which is really just x plus 3. All right? Another way we teach it is if you have an x squared, your answer is going to be 1 degree less. So if I have x squared, if I'm using synthetic division, my answer is going to start with a linear term, so start with an x. All right, let's try number 2, and I promise this will be easier. Make your little box and say, okay, if I have x minus 8, my 0 is positive 8. So be really careful because obviously you're going to mix up all the signs if you're not putting the correct 0 in. Put all the coefficients, so 2x squared, negative 19x, and 24. I'm going to draw my line and bring down my first term. Once I bring down that first term, so no matter what number it is, bring it down, I'm going to multiply, so 8 times 2 is 16, and then I'm going to add going this way, so this would be negative 3. Multiply again the bottom number by what the 0 is, so negative 24, and add to get 0. My remainder for this problem would be 0. This would be my constant term or my number. This would be my x term. So it's 2x minus 3. Now if you look, kind of scroll up to the very beginning, that was the same problem as number 2, and it takes a lot less effort to do synthetic division than it does to do long division. All right, let's try number 3. Number 3, x plus 2 is what I'm dividing by. So my 0 is going to be negative 2. Make sure you put in the opposite. Now, this is a tricky one. Again, just like before, it was tricky because I had to put a 0x squared in for my long division. I have to make sure I have a placeholder for anything that I'm missing. If you don't, the problem's going to be wrong. So please be careful when you do this, and please be careful to put in placeholders, meaning I have 1x cubed. I don't have any x squared terms. So since I don't have any x squared, I have to put a 0 in. I have minus 3 for my x term and 8 for my constant term. Then after that, it's just the same as what we've done before. But if you don't hold this placeholder, you're telling like it's a different problem. You're making it a kind of a cubic, and then, or actually you're going to make it a squared term instead of a cube term. So make sure you put this placeholder in if you're missing a term. Bring down the 1, multiply the bottom number by what the 0 is. So 1 times negative 2 is negative 2, and then add going vertically. I'm going to multiply negative 2 times negative 2 to get 4. I'm going to add negative 3 plus 4 and get 1. Multiply again going diagonally. 1 times negative 2 is negative 2. And then I have 6. So now I have a remainder. This is still my number. This is still my x term. Now I have an x squared term. And that should make sense what I said before. If we're dividing an x cubed, the first degree for my answer should be an x squared. So to interpret this answer, I'm going to say 1x squared minus 2x plus 1. My remainder is 6. Put that over whatever your divisor is. Now be careful. My divisor is x plus 2. Don't just put the 0. Put what the divisor is. All right, go ahead and try number 4 on your own. When you're finished, come check your answer. So press pause in the video now and try that problem. Okay, if I'm dividing by x plus 1, my 0 is a negative 1. My coefficients are 1, negative 2, 4, and negative 5. I'm going to bring down my first term. I'm going to multiply and then add. I'm going to multiply and then add. I'm going to multiply and then add. I'm going to box this off. This is my remainder. This is my constant term, my x term, and my x squared term. So my answer would be x squared minus 3x plus 7. My remainder is negative 12 over, not just negative 1, over x plus 1. And that would be the answer to that problem. So you're going to wind up liking synthetic division a lot better. The problem with synthetic division is we can only do factors that I can get zeros. So I can't do something like, let me scroll back up. I can't do like this problem, I can't do by synthetic. Okay, because x squared minus 9, if I were to get a 0, I have 3, negative 3, and sometimes I'm not going to have anything. So you can't do all problems by synthetic. So we'll talk about that tomorrow. The last thing we're going to do quickly is that your homework is going to ask if something's a factor. Okay, if you divide and there's no remainder, then the divisor is a factor, right? So if I have like 8 and I say, is 2 a factor? Well, if I divide it and it goes in evenly, I'm like, yes, it is. So the same thing is going to hold true. If they ask you if a polynomial is a factor of another polynomial, do synthetic or long division. If there's no remainder, okay, then it is a factor. So if there's no remainder, it is a factor. If there is a remainder, then it's not a factor. So I'm going to do synthetic division here. I'm going to put 5 for my 0. I'm going to put my coefficients of 1, negative 17, and negative 15. And really, all I care about is my remainder. If my remainder is 0, it's a factor. If my remainder is a number, it's not a factor. So bring down 1. I'm going to multiply and then add. Multiply and then add. Multiply and add. Since this is 0, then I would say yes, x minus 5 is a factor.